In this lesson, we're going to introduce the concept of pump performance. A pump performance typically varies with flow rate. That means that different flow rates will result in different supplied pump heads. In theory, that is, assuming steady uniform flow, no friction or other losses, and several other simplifications, this relationship can be linear. However, in practice, this relationship is more complex. Because of this, manufacturers often supply pump performance curves. These pump performance curves are created with data obtained from measurements. They relate a pump's flow rate to its supplied pump head. Usually, these curves will also include an efficiency curve that relates a flow rate in a pump to its efficiency. That is, the ratio of the power supplied by the pump to the power required or extracted by the pump. Here's an example of a pump performance curve. Notice that the pump head curve, that is the darker blue line, decreases with increasing flow rate. This will be a common characteristic of pump performance curves. The efficiency curve, that is the lighter blue line, is plotted using the y-axis on the right side, which is in percentage. Notice that the maximum efficiency is not necessarily reached at the maximum flow rate. Also, the maximum efficiency will most likely not coincide with the maximum pump head. Some pumps have multiple settings, such as RPMs, impeller diameters, and other settings. When that's the case, pump performance graphs will typically include multiple curves that represent the multiple settings for the pump. In this example, we have 3 pump performance curves for 3 different impeller diameters. When this is the case, the efficiency curves are usually plotted in the way shown in the image. Notice that the efficiency, that is, the curves that measure percentages, tends to increase but reaches its maximum point somewhere just before 24,000 gallons per minute. The other 2 curves, the brake horsepower and the net positive suction head, will not be covered in this lesson.